Welcome, everybody. Thanks for joining us today. You're going to be hearing from Anna Glander today, who's a senior DevX engineer at Materialize. And she's really the perfect person to give this talk because she has experience working as a data analyst, then a data engineer, and even a software engineer on the observability team. So this is like the perfect sort of combination of topics for Anna to talk about. And my name's Andy. I'll be giving quick context on Materialize and Dbt and helping answer questions at the end. So I'm just going to give like a 3-minute intro to Materialize and Dbt just to make sure we're all on the same page and caught up. If you're already familiar, now would be a good time to get some tea or just listen through this. So we call Materialize a streaming database, and here's what we mean. It talks like a database. It's Postgres wire compatible. That's part of what makes it a natural integration with dbt. But under the hood, it's different. Traditional databases recompute results on every query, and Materialize flips it around and asks for your queries up front and incrementally maintains the results using a stream processor. So the work is shifted from the read side to the write side. And this dramatically changes your capabilities. So not only does this mean that read latencies are comparable to Redis, but it also means that you can subscribe to updates to a query or sync changes out to Kafka. So just to really cement the idea of Materialize in your head, it's a database, it's a stream processor, it's a combination database stream processor. So I promise that will be the only bad meme today. And then on the dbt side, what is dbt? This is probably new to more folks here. dbt stands for Data Build Tool. It's an open source transformation tool that allows anyone comfortable with SQL to author their own data pipelines. I see it as kind of a power tool for analytics engineers that was clearly built by very thoughtful people at the intersection of data and software engineering. So it brings a lot of the best parts of developer workflows to the data world. And how does it work? It sort of orchestrates your SQL transformations inside of your warehouse or database. So you're typically following the ELT extract, load, transform process where all your raw data is loaded into your database or warehouse, and then you build up transformations in the form of SQL views or cache tables using SQL and dbt's templating language. And then you use their runner or their CLI tool to execute those transformations. And along the way, you get a bunch of software development workflows, like everything is in code. So you're able to work more modularly. And then you get a version control. It's built to be used in a Git workflow. And what we're talking about today is you get testing. There's a dbt test command and a concept of SQL-based tests. And after that, or using that, you can build CI/CD type of workflows. And then lastly, pretty interestingly, they have documentation. So you can auto-generate lineage graphs based on your views and documentation about the tables and columns you're building. And then one last note on dbt and Materialize, they integrate via an adapter, which was actually first started by Josh Wills, who also had the idea for the dbt test concept that we're going to run through today. And there's an adapter for every warehouse or database that basically helps you adapt to any specific behavior of the target database. So in the case of Materialize, the main thing that is different is the materialization option. In typical warehouses with dbt, you have a few options for persisting your data. You can write it as a non-materialized view, or you can cache the results as a new table. And among other things, the main change with the Materialize adapter is it lets you persist your views as materialized views. So you'll see that in action today. And then before we get into it, I've almost forgot to give out a special thanks and shout out to Josh Wills, the man in the big hat here, who originally came up with this idea back he prototyped it at a hack day we had in February, this idea for running continuous tests with Materialize. So I think it's like a great example of at Materialize, we're experts at Materialize, but where some of the coolest ideas come from is when we get it in the hands of somebody who's an expert in a particular vertical or their own practice, and they come up with a new way to use Materialize. So hopefully we come up with more of these in the future that are all coming from the community. Okay, so with that, I'll hand it over to Anna to walk through the fun part. Anna, if you want to take over screen share.
Hi, everyone. Can everyone see my screen?
Yep.
Okay, awesome. So thanks, Andy, for the intro and a great description of what we're going to be doing. And also special thanks to Josh for all of your help making this happen. And I'm going to keep this pretty informal. I have the system that I'll show you here running right now, and I'll interact with it sort of as an explainer as we go. As Andy mentioned, please do chat your questions to us and we'll make sure to get to them at the end. So I'm hoping that this is a familiar setup for most of you who've interacted online before. We chose to go with a super simplified version of an e-commerce store. So our backend is a Postgres database. We have information about our users, what they're purchasing, and which items go along with those purchases. And then we're also collecting information from our front-end application, in this case, in the form of segment events, specifically page views. And that's coming to us via Kafka and specifically a page views Kafka topic. We'll use Materialize to ingest this source data, and we'll use dbt to transform it into something that analysts can interact with and present to stakeholders, or something that an event-driven application downstream could use to send notifications to users. We'll also use dbt tests or dbt to run some data quality tests. dbt ships with this test functionality, as Andy mentioned, and I'm super stoked to show you how you can use it not only in development, but also in production, so that as your data streams in, if conditions are violated, you'll know right away. We'll do that by showing you just a little mock script to turn the information in our test views into Prometheus metrics. And Prometheus will ingest them and Grafana will visualize them so we can have a time series representation of what's going on underneath us. So I gotta move this. Okay. So as I mentioned, have all of this running locally. I have hopped into the dbt container. Generally, the first thing you do when you're developing a dbt project is install your dependencies. I've already done that. The next thing that you do is run your models. We've taken the time to write them and test them already, so we should have no problem just executing dbt run. With Materialize, you only need to run dbt run once and all of your models will be created for you. There's no need to run a batch update of the dbt run command because materialized views in essence are updating in real time based on the data that's flowing through our source. So as you can see, we've created two source models, one for our Kafka, the data flowing through Kafka, the other for our Postgres information. We've created a bunch of staging models in canonical dbt format just to better translate what's happening in our tables to analysts and folks querying them. And then the real work happens below in our dimension tables. We've created two, one on the user level and one on the item level. And these aggregate information both from our transactional database and also from our web analytics. So the next thing we'll do is run dbt test. And what this is doing is executing a query for each of the test conditions we've defined on our model. We've asked dbt to do something special here. We've asked dbt to store failures for these tests. That flag in other databases makes tables which contain error rows if applicable. With the dbt materialize adapter, we've updated it so that for every test condition you define, we'll create a materialized view under the hood. This view shouldn't have any rows in it right now, as we can see these do not. But if a condition were to fail, we can understand in real time if rows have been introduced into these tables. So we've just shown you a couple of examples here. DBT ships with 4 that are most commonly used, checks for uniqueness, checks for non-null or null values, checks for a set of accepted values within a column, and checks for relationships between columns. We've added one step specific to this tutorial. We're going to run a little macro that will just union the output of all of our test materialized views into one materialized view and count the number of failing records for each. We've done this just so that we can more easily work with the data downstream, and I'll show you more later what that means. Great, so we've run everything we need to in DBT. Let's hop over to Materialize and check out what's happening. So first, let me show you what our dimension tables look like. Here's dim users. We have, again, information aggregated by user ID. We have information about revenue and page views and some other stuff. I'm just showing you just a bit. And then our dim items table. This guy contains information about each item, the number of items sold, page views, and our conversion rate, which is a calculation based on both of those things. So I'm querying this table right now. If I run this query again, we can see that in the last, however long it took me to run that query, we've sold, around 100 items, and the data is updating underneath us in real time. Let's move on to talking about our tests that we ran. We've elected to store our failures in a schema called test. DBT suffixes appends this to the target schema so that we can more accurately understand how tests are related to their respective models. And DBT created, 6 materialized views for us when we ran that command, which is really great. And then we see that our ETL alert view, which is our unioned view of all of these, has also been created for us. There shouldn't be any rows in this. Sorry, we need our test schema. Great. So nothing's firing right now. Our pipeline looks good. So let's muck something up. Let's assume that we're about to be selling a new product. It's really exciting. The billing team is updating our underlying Postgres database to account for this. So we're going to insert a row into our upstream Postgres database, and we don't know the price of the new item yet. So we're going to set that price to null. So we can see right away when we made that insert that 2 alerts are firing. One on the staging level, right? This is telling us that in fact, there is a null price set on our items table. And then awesomely, one more is firing for us. This is downstream of their staging data on our dimensions table. And in this case, this is just telling us that we need to handle that new value in our reporting and analytics view. I've been querying Materialize ad hoc, right? Because I know that I'm updating the underlying Postgres database. But Materialize's power really lies in the ability to subscribe to changes in materialized views so you can know when they happen and you can receive updates. One way to do this is by Materialize exposes a tail command, which is quite literally just a subscription against a materialized view. And you'll receive events from that subscription when a materialized view changes. So let's execute that command. Awesome. So we can see now, we've received 2 updates. We've just selected from our alert view and asked to tail that command so we can see it. We can see we received an update when our accepted values alert fired, and also an update when our staging null price was introduced. This is a timestamp internal to Materialize that helps you understand when something happened. And this is what we call an MZDiff column. It basically denotes if the update was actually an insert into the Materialize view or a removal. So let's say that we've figured out what the price of the item is going to be. And we'll update we'll update the price. Let's say it's set to $200. And now we can see that immediately no longer is our initial staging condition firing. We updated the price, and so that row was then removed from the materialized view. We still have this accepted values alert firing, which is important because again, we need to handle that condition in our downstream modeling. For instance, if a certain set of products summed together meant a certain class of user that we wanted to track. And then we can see down here that we received another update from our tail subscription, this time telling us that an alert row was removed from our alert table or alert materialized view. So we've been running this tail command just interactively, but we've also shipped this demo with a tiny little Python script that basically just collects all of the updates and aggregates them by view name and then surfaces that information via a Prometheus metric. So it's just a little exporter / translator. So I'll show you what the metrics themselves actually look like. So down here, we can see that we're exporting two metrics. They're both titled ETL alert rows, but they have different labels in our label set. The first is the dim items accepted values alert that we saw, which has not yet resolved. So we still know that there are two rows that are offensive there. And then we have our staging alert, which we resolved. So the value now has become 0. What this looks like in Prometheus. Prometheus is set up to scrape this endpoint with our metrics. And so we can see over time what is actually firing. And what we'll do is contain to where this metric is greater than 0, and that will give us just the actual alerts that are happening. So then in Grafana, we've decided to break our alerts out into two different graphs. The first graph is for staging alerts, those alerts which sit right on top of our source data. It's likely that data engineers will be interacting with these more just because they know what's happening in the external data sources that we're consuming from. And then here, the production alerts are probably going to go to the BI team or the analyst team, those people who are responsible for updating the code should there need to be any changes in the transformation layer. There are a bunch of different ways that you can get alert style data out of Materialize. This is just one of them that we've decided to showcase to show you how to take advantage of observability best practices. And because I love observability. Alternatively, you can sync data back out to Kafka. You can sync your alert view back out to Kafka and operate it on it there. Or you can use a compatible BI tool. Some come with the ability to set alert conditions on some condition that you define. You lose a little bit of Materialize's power though there because you're querying a data store on some, or you're querying Materialize on some cadence instead of operating on the subscription itself. Oh no, it looks like another alert is firing in this case, which we can see from our tail command. So this means that an alert is firing that the number of records is changing quite often. So it looks like something that's a little more long-term than us just mucking with the database. So let's take a look at what's happening. Okay, so we've got a new alert firing. And it's called unique DIM users ID. This means that the DIM users table is no longer unique on the user ID level, which is obviously not great for downstream reporting. So we can see that DBT has enabled us to figure out what exact field this is failing on, which is super helpful. So that means we can go and select from our DIM users table. To see what an offensive record looks like. I'm gonna pick just revenue and cheat a little bit. Okay, so digging in a little more, it looks like we're double counting, or we have two rows where there should be one, right? But revenue information is the same. Page view information looks a little different. So our next item of business is to go check out what could be happening on the page view side of things, because this looks to me like something might be mucked up with the join. So let's take a look at our join. Okay, so this is our dim user materialized view created via dbt. We've got two subqueries, one page views and the other purchases. It looks to me like our page views subquery is grouping by two fields, the user ID and the email. And our purchases view is only grouping on the user ID. So that might be what's happening. I'm going to cheat a little and tell you what actually happened. Under the hood, our web analytics code got a little mucked up, and we somehow were emitting records events with user IDs, but blank emails. So what that did was that caused this subquery to have two rows for each user ID, one with the correct email and one with a blank email. Then when you join that to purchases, that will duplicate every row, and that's how you see the resulting muck up in the join. This is pretty bad for, revenue summations, and it could lead to quite a few Slack messages and questions about your data structure. I'm sure most of you have come into contact with this at one point or another. So enabling you to understand what's happening really fast. I mean, that took us all of a couple seconds to diagnose, and we can get an analyst in there correcting this SQL as soon as possible. And we have lineage into what happened way quicker, so we can speak to product and engineering and close the loop on what could have been going on underneath us super quickly. So that's sort of all I have. I'd like to hear from y'all. If not now, then if you try this out, this is the first time I've played with it. And there's tons more to do with DBT test. There's a ton of writing about it. The community is super behind it, obviously. And so we're super excited to hear how y'all might be using this. So please do reach out to us in Slack. We'd love to hear from you. That's it.
Thanks, Anna. All right, let me take over screen share. If anybody has questions, I think there's a couple that came in. One second here, I'm not sure. Okay, so just to summarize, this continuous testing idea is using the existing DBT test paradigm. Each test query is a materialized view, and every new input from your source streams is processed through the tests, and you can query, subscribe, or sync test results out. So it's kind of this primitive that we saw a couple applications of using it today. I think I read this week, somebody from the community wrote a blog post about using something similar for ML ops type of work. So tracking monitoring the effectiveness of a machine learning model in production. So I think there's a lot we can do with this. Would definitely be curious to hear your experience if you play with it. This demo, just for context, was using the materialized binary. I sent a link in the chat with the GitHub repo that Anna worked through, but there's also what we're building, what we're putting all of our future development into is the distributed version, where it's basically going from the binary. You can think of like Postgres, and then the distributed version is more like Snowflake, where it separates all of the different services in terms of like ingest, storage, compute, and we manage all of that in a cloud platform. So if you're interested in getting access to that, sign up at materialize.com/early. And with that, I think there's a couple questions. Oh, I see, Anna, you're answering one of them. This one came from Josh. I think it was a softball, but Josh asks, how would I automate the unioning of my tests into a single ETL alert view? That seems really handy. Anna, do you have an answer for us there?
In this case, I just wrote a little macro that listed all of the tables or the materialized views in my test schema, and based on their title told or did what I needed to do to union them together. And you can run that right after your initial test run, and that will continuously update, and no need to rerun that again.
I think there's also the wait, I have a tab open because I think Josh is also.
Josh, chime in.
Can we allow, or let's see, I have to like upgrade his status to presenter, but there's also like.
Yeah, we've been thinking a lot about this internally. So go ahead, Andy.
Oh yeah, I was just going to say there's also this idea of like dynamic union. So the union thing, you're able to do that when you create the union, but then if you later add a new test, the way to do it today would be to just recreate the union also. But in the future, we're thinking about a way where you're actually dynamically just adding in tests to an existing union, which would allow for some more continuity there.
Nice. Hey, everybody, it's Josh. Thanks for letting me talk, Andy. I appreciate that. And thought leader, huh? Really? Okay. That's well, I'm gonna do some.
The highest compliment, Josh.
Was it really? Okay. All right, fine. So sorry, Anna, is that like running that macro? Is that like a DBT run operation, or how does that macro run?
Yes, it is.
Cool.
It is a DBT run operations that or just one that just creates that.
Right on. That's awesome. Makes sense. Thank you for that. That's cool. Is it like in the repo? Like, can I go see it?
It is. It's under the macros subfolder.
Awesome. Thank you so much. I will
Yep,
remute
I'm
myself.
sure you'll have ideas for me about how we can improve that too. So happy to talk through it.
Awesome. Thank you.
Yeah, I can actually show it. So this is the SQL that's unioning together all of the alerts, and you would just run it with a dbt macro, make alert view, and then specify the schema name and an argument. There's also a question for, is there support for this kind of alerting in the cloud product? Yeah, the cloud product, the way to think about it is if you're testing out using the binary, the cloud product has the same capabilities and same SQL interface. It's just got a few, so it's distributed. So there's separate scaling of storage and compute. And then it's also storage in the binary. It's more of an in-memory view maintenance engine where there's no persistence of data between restarts in the binary and in the platform there is. So definitely support for this in the platform. And then Robert asks, can you sync or write the test results out of Materialize into another database or file storage?
You want me to take that?
Sure.
Yes, you can either write using any of your favorite programming languages. You can execute that tail command and then use those programming languages to send data elsewhere. Some other folks have gone the sync back out to Kafka and then connect to Snowflake route via like a Kafka connector. That could be possible. It sort of depends on what you're doing, but yes, most definitely.
Okay, I think that's all of the questions. Oh, Josh Ehrenberg, another very influential Josh in Materialize ecosystem, mentions the cloud product needs a tail to Slack add-in. Yeah, actually, I don't know if you were joking or serious, but the way we think about that is HTTP syncs. So we have Kafka syncs today. Maybe I can't make any promises, or engineering will come and unplug my internet. But HTTP syncs, if you think about like just that as a primitive, would give you some of that ability to just hit a webhook like a Slack webhook. So it's not crazy. Okay. Any last questions? I think that's it. So with that, we'll wrap up. Thank you so much, Anna, for walking us through that today. And have a great rest of your day, everyone. Thanks for joining.